Draw the two chair conformations of menthol and tell which is more stable. So I'm just going to draw a chair form here. Just arbitrarily pick one of these carbons to be the one carbon. So let's just make this one here. Well, I'll make this the one carbon. Why not? So this is one, and I'll put the isopropyl group here going up. Okay, so there's an isopropyl group here going up, and a hydrogen going down. So if I call this one, let's just see if I want to, I'll call this one the 2 carbon, and if the isopropyl is sticking out, it's up, the hydroxy is going back. These two are trans to each other. That means that the hydroxy, the OH, needs to be on the other side of the ring from the isopropyl. And since it's on the next carbon, it's easy just to put it on the next carbon. Since we numbered, it makes it a lot easier. 1, 2, 3, 4, 5, 6 around this ring. So we'll start numbering here. 1, 2, 3, 4, 5, 6. So where is this methyl? It's on the 4 carbon. So since we've already numbered it, we know it's on this carbon. Which way is it pointing? Well, since the methyl is going back and the OH is going back, these two are cis to one another. That means the methyl has to be here, pointing down, just like the OH. And both the OH and the methyl are trans to the isopropyl. So this one right here, CH3, CH3. Okay, so draw the 2 chair conformations. Well, now we have to flip the chair. So we'll drag the first carbon down and the 4th carbon up, and that will give us this chair here. And since the 1 carbon is, since the methyl group, just going to erase that, sorry, since the isopropyl is pointing up and axial in this chair form, it stays up, keep my pink substituents, it stays up, but what was axial becomes equatorial. So here is our isopropyl. And now let's just go on around the ring. So this was carbon 1 here. This was carbon 1. This is 2. And this is 3, 4, 5, and 6. So the OH is on the 2 carbon. It was down and axial here. So now it's going to be down and equatorial. So there we go. There's our OH and our H on the 2 carbon. And then going on around the ring, the 4 carbon had the methyl, so it was down and axial, so now it's going to be down and equatorial. So here's the 4 carbon. And the question is, so we'll just draw our little equilibrium arrows here to indicate that this is a conformational change between these two. Which is more stable? Well, this is pretty straightforward because in this case we have 3 axial substituents, whereas on the right we have 3 equatorial substituents. So this is clearly the more stable, by quite a bit, conformer or chair form than this one, because we have all equatorial versus all axial.